Hello guys and fellows, this proposal is a little bit late, although it was scheduled to be presented 2 weeks earlier at office hour 4 or 5, and the reason for delay is that surgeon overlooked something during my operation which caused 2 more surgeries and a longer absence for me from fellowship. So errors happen no matter where, and sometimes things happen unexpectedly, and sometimes doesn't matter how professional you are at your job, some unpredictable things will happen and mess everything up. And I think it's okay and normal if you can't predict every possible case, but when problems somewhere appear, it's necessary to know where to look and be efficient. So let's introduce project proposal, which will allow us to look in the right place at the right time. And it's about implementing Tokio tracing for debugging and performance analysis. My name is Vukasin Markovic, and this project is for Grandine. So at start, let's just tell why is this project proposed, and the answer is obvious. Cause deep observability is essential for Ethereum clients, especially for high performance ones such as Grandine. And with the possibilities that tracing brings, correctness, stability and optimal performance will be more secured. So the problem currently is Grandine relies on basic logging solutions, and because of lack of context awareness in that solution, debugging complex async workflows become our nightmare, I can say like that. And for non-Rust colleagues and fellows, I owe explanation of few terms to get more clear picture about what Tokio tracing is doing. And first you need to know is that, like many other languages, Rust also supports async await syntax, but in Rust case, this async code is like just a recipe for cake, and it's nothing without baker who will execute that recipe. And the most favored executor for that is Tokio. So Tokio is our cake baker, and Tokio support async performance profiling via tracing subscriber. So let's talk about that. How is this possible? In tracing, the concept of spans provide a clear view of async workflows and their relationships, and that is possible because a span represents a timed operation with start and end, and all events within spans are linked to it. So in contrast to all log info, which produce context-unaware messages, new tracing info, when used inside the span, creates an event tied to broader context. And this approach is already proven in Lighthouse. So there is visual representation how it needs to look. And at first, we are going to instrument critical asynchronous components with spans and give that data to tracing subscriber, who will provide us flexible filtering and output layers. So let's take a quick look at the final possibilities and benefits that tracing subscriber provide to us. First one is console log. It's the basic one, and using tracing subscriber gives us more powerful and configurable logging, which we can see at the bottom image. And there is included thread IDs, file names, line number, etc., etc. But the main benefit of tracing is not improved formatting. So let's switch to Tokio console, and it displays a list of async tasks in program, and there we can choose and enter one and get more detailed information about that task. And in flame graph case, additional layer of tracing subscriber is tracing flame, and it can convert tracing events into flame graphs JSON format, which is compatible with flame graphs tools such as Inferno. And there we get something like this. This is flame graph, and there we can see a visual representation of hierarchy of function calls or spans, and longer duration result in wider blocks. So at the bottom there are main tasks such as main or Tokio runtime, and as you go further up you will see functions that were called from the ones below. So here is roadmap finally, and it is divided on 4 phases, where first one is foundational setup, where I will enable tracer who will replace old logging system. Second phase is about network instrumentation and trace API endpoints and peer-to-peer segment. Third one is for core logic instrumentation, such as fork choice rule and validator duties. And fourth phase is for final migration and optional advanced tooling. And there, sure, I have some challenges and trade-offs, so let's mention them. One of the challenges will surely be performance overhead, where I need to carefully benchmark to ensure tracing doesn't slow down critical paths. Another one is the complexity of async code, and trade-offs needs to be made between debug mode, where I will provide detailed spans, and info mode, where I need to provide minimal code instrumentation. So the goal is for this project is to have full structure tracing across core components, configurable logging and profiling that can be enabled in development mode or production mode, minimal performance impact in release builds, and I will provide clear guides for developers and operator. And the main one is we will have improved confidence in performance and correctness. So thank you for your attention. There is no question section because this presentation isn't live, so feel free to comment your question or suggestion. It's okay, I will reply to all of them.